Okay, so very sorry. Since I start record, you need to turn on your camera and speaker again. Yeah, thank you.
Okay, can you hear me?
Yes, yes.
Okay, so let's start our presentation. Okay, hi, hello everyone, and welcome to the Matrix Robotics webinar section 3. And I'm Barry, and today we will be diving into an exciting world of building, programming, and tackling a mini challenge with the Matrix. Before we get started, I want to share a link where you can access example files and results that will be helpful during and after webinar. You can find them at this link. Feel free to download this material and might be useful to follow along or for your future reference. So let me copy and share to you guys. Okay, let's back to the slide. In this session, we will go through robot assembly using future innovator sets and backseat programming with matrix block, and then testing and debugging. We will end with a mini challenge and open discussion. A key tool for programming our robots is the matrix block software. If you haven't already, please download and install it. And you can find the software at Matrix Robotics website. Let me show you how to download and install it. Open your browser and search Matrix Robotics and click first one. And you will see a download here, and just double click Matrix block. Download now. And choose your controller. And today we're gonna use Matrix Mini R4 controller. So let's select it. And my computer is Windows system, so I will download for Windows. I think I already installed it, so just double click it. Agree. During it is installing, let's back to the slide. Okay, all right, let's start with first the fun part of robot assembly. This is where we get our hands busy and start building with future innovator sets and get ready to become robot builders. This is where the magic happens, folks, as we transform a bunch of parts into a real working robot. So I stop here. Let's pay a close attention to how all these pieces fit together. Here's the part lister for our robot. It includes pins, connector, and motors, wheels, and more. check the quantity, they are important. So now let's start to build a robot. We will have a two wheel and a one battery box, one matrix mini alpha controller, and two DC motors and two servo motors. Let's get started with the first step. Let's take this C-shaped beam and the one flange plate and connect it together. Use this black quick connector. Okay. Next, you do the same thing on the other hand.
So I see we have some new people coming in. Just keep your hands up. We are doing the hands-on session. So if you have the robot and you would like to try, you can follow Barry's step. But of course, after we will share the document, so you can build the robot after the session as well.
Yes. I think everyone is good. So let's continue to our next step. Step 3, let's use this L shape beam and connect it like that. Okay, cool. Let's take this a steel ball at there and use this wide quick connector to connect it together. Okay. Next, use another L shaping 5-hole, a shorter one, and connect it at there. Use a black quick connector to connect them together. Next, let's take a DC motors and connect it at there. Okay, the next, the other one. Okay, looks good. Let's connect the wheel on it, and it might be a little tight, but it's normal. Yes. So now you will have a basic chassis. Let's get into the next step. And let's take this servo motors in this side That's connected. The other side. Okay. Let's continue. Let's take this, the plate beam, and connect it at there. Okay. Take this L-shaped beam. To the mystic. Oh. I did wrong. Sorry. Need to change the position with DC motor and the RC motor. Sorry, guys. Okay. Okay, I think I fixed it. Let's continue and use this L-shaped beam. Connect it at there. Okay. Next step, let's put the battery box in the robot. Like that. Okay. And next, let's put your Matrix Mini Alpha controller on the robot and use the Y quick connector to connect it. Okay. Let's continue to the next step. Take this longer L-shaped beam. Connect it at the layer. Okay. The other side. Same. The final step. Okay, we have done with our robot building. All right, everyone. Now we are going to do the actual wiring. And I've got the controller here, and this is the brain of our robot. And we need to connect the DC motor and the servo motor to it, so it know what to do. Let's start with the DC motor. I'm taking the motor connector here, and notice it has a black and a red wire. And now I'll control. Sorry. We have a motor port, and this is super important. And see this tiny dot, next to the motor port. That dot tell us where the black wire need to go. So let's plug it. Black one go to the dot. And let's plug in the motor encoder wire. Okay, now for servo motor, here's a servo motor connector here. It usually have a brown wire, a red wire, and an orange wire. We are plugging this into the servo port. And just like with the DC motor, we have a dot here, and this time the brown wire need to line up with the dot. So let's plug in. Okay. Now we did the same thing with N2. Okay. Now we have done with the wiring. Now we transition to the part of basic programming. We will be using the matrix block, a beginner-friendly visual coding platform to control our robot movement. Matrix block simply fits the coding process by using drag and drop interface, make it easier to understand the logic behind robot motion programming. Matrix Block has a new update with the great improvement. We have added support for WFI, double future innovate, a new scratch block, and also we fixed some problem. We recommend you update your software, get the update with the Matrix official website. Let's get familiar with the, the Matrix block interface. This is a quick overview. The block box is where you will find all the coding blocks you need. Your code area is where you drag and arrange the block to create your program. For those who want to see the source code, there is a C++ code view. And the information window allows you to send parameter back to the computer, and you have a toolbar for various functions like some easy sample or to update your firmware. And the control area is like you select your COM port and your device to upload the program to your controller. So now you can open Matrix Block on your computer. I already installed it. So let's get it started. In a block box, you can find so many blocks, so many functional blocks you need. Like we have a mini core, we have a mini button and battery voltage, and or some motor or sensor. We have a RGB LED and a buzzer and a LED screen, a serial port, and NJ2 joystick, some sensing. So you can find the analog sensor or digital sensor at LAN or I2C or I2C sensor. Third-party sensors, timer, and some control. Okay, let's back to the slide. Let's start with controlling our robot motors. First, we need to understand how to set the motor directions. As you can see in this slide, we can control the direction of rotation. This is crucial for making your robot move forward and backward or turn. We can control the DC motors using relative degrees, which is useful for precise movement. So let's start to programming. We need to use a main program, and we need to set up the motor direction, set up RC motor, RC1, and RC2, and DC motor N1 and N2, and checklist light. And we need to change the direction with RC1 and N2. So RC1, RC2 off, and N2. Yes. Okay. And additionally, in servo motor, we can control servo motor using absolute angles, giving us another level of control for specific applications. Now we use we use screwdriver to remove the servo motor wheel. Use your screwdriver to remove this screw. Remove the servo motor wheel. Because we need to reset in the servo motor angles. Plug the battery power cable and press this button for 2 seconds to open your controller. And use USB-C cable to connect your controller to your computer. And let's back to the matrix block. We need to set your servo motor to 0 angle. So let's use this servo motor set position to 0. And RC2. And choose your a correct comport and upload it. And then your servo motor will turn to 0 angle. Now, that's it back. Okay. Hmm. And now let's coding this program. You need to create your own block. So let's make a block. I want to call this block to move tank and add 3 normal input and 1 string input. And first one is N1 power. Second one is N2 power. The third one is distance. And add a string input. This is break. And then click OK to create it. And I want to make this program make my robot move a wheel and then brake So I need to reset the motor encoder. And then we need to move the motor. So we use this DC motor and power. N1 for N1 power and N2 for N2 power. And I want to make him move the wheel until the distance, until to the specific distance. So click Control. Sorry. Click Control. Repeat until we need to read the motor encoder. N1 and N2. We need to do degrees of average. Absolute. And N2. And add both. And then times 2, divides 2. Divided by 2. And repeat until my average, my degrees of average to specific distance. So I need to use this more block. Put distance at there. And put this 2 block in this loop. And after it move to the specific degrees, we need to break the motor. So if I want to break the motor, then I need to type the break into this. So if break equal and type break. Then I need to break the motor. So we use DC motor and DC motor break N1 and N2. So now you can make your robot move forward, move to the specific degrees, and type your motor power into there. And if you want to make it move 30, 60 degrees, then you type it. And you want to make it break, so you type break. And let's see how it's work. Upload my program. So let's do it again. Okay. When motor return to 3060 to 360 degree, and then it will break. But if you type no, let's see what's happened. Okay, you can see the motor won't stop. So if you want it to stop, you need to type break. I want to make sure. Okay. So now let's control our servo motor. The same, we need to make my own block, and this block called servo, and add two number input. The first one is angles. The second one is delay. And if you want to control our servo motor, we need to use this block. Servo motor step position. And we need to control RC1 and RC2. And put angle with there. And use the weight to make servo motor can run for a wheel. So let's see what happened. I want it turn to 90 degrees and run for 1 second, 1000 milliseconds. Okay. As you can see, the servo motor turned to the 90 degrees. So everything looks good. And if you put your program at state up, it will be just wrong for once. But if you put your angle at a loop, it will run infinitely. Like if you program it like that and upload. And your box will be a rise and down, rise and down, rise and down infinitely. It won't stop. You need to put your program at lane. Okay, let's back to the slide. Now let's talk about a very important part of the progress, testing and debugging. Uh, Here are some common issues you might encounter. The first one, why I can't upload my program. Here's a main reason. Maybe you forget to open the controller. You must be open the controller before you upload the program, or your code have some bug. And let's do some example. Here is a, a number input, but if I type some word, and then upload. Okay, you will see compiler upload failed, and you can screw up to view the error message. And you will see here was not declared in this scope. So let's change it back to the 19 and compiling again. Yeah, that would be successful. Compiling failed, but I don't know why. Just like I do, you can screw up to see the error message. Number 3, successful uploading, but motor still doesn't run. Why? Maybe you forget to open your battery box power switch, or the motor power that you set is too low, so you need to increase the power. And number 4, the screen on my controller shows a firmware outdate. How can I fix this? A firmware outdate, then you need to update your firmware. How to update your firmware? You need to prepare something like a pen or some pin and plug it into this hole, DFU plugin, and connect your USB-C cable. And you will see the blue LED here. And then open your matrix block and type there. You will see the firmware update. And click scan DFU device. Okay, scan successful. And select firmware and define your firmware. If you don't have a firmware file, you can place this to download our newest firmware. Download. Select again. Download. Here, open. And update firmware. Okay. Now disconnect your controller and connect it again. And open your controller. You will see the newest version. Now back to the slide. And I think we don't have enough time to do this challenge. So let's take a look next. If you want to do some advanced function, then you can try to use Arduino IDE to coding. This offer more advanced control and flexibility, but it is generally recommend after you are comfort with matrix block. And if you have any question, you can feel free to ask it now.
Thank you, Barry, for walking us through. So I hope everybody enjoy the session. So today we try to like build a car, and also Barry show us some of the software, like how to work with your R4 controller. And yes, I think we still can have the mini challenge. So we will post on our social media if you try on. After that, you can sign up and associate level certification. Yeah, so I think this is for today. And I don't know if anyone has any question regarding on the training session, on the workshop. We have Zartard. Hello. Thank you. Yeah, and we
Hi,
have
Daphne. Hi, Barry. Thank you very much. I was just unmuting myself. I don't have any questions. It was very self-explanatory, and the way Barry explained everything, I think it made sense. I just wanted to know if a recording will be shared for this, because I'm conducting a session next week where I am demonstrating the kits. We have some orientations planned next week where we're showing the kits as well. So I think it would be helpful if I can give them an idea that such webinars are available to understand the usage of the kits. So I just wanted that if a recording could be shared, I will be able to show some parts of it. Thank
yes,
you
of
very much,
course.
Barry.
Thank you. Thank you, Zartard.
Thank you.
Thank you,
Thank you.
Barry. Yes, we will share the recording, and I think Barry already shared the all the I think presentation everything in the link, so you can
Yes,
find out.
yes.
Yes, so you can download everything like on the presentation, and I think some of the sample code, right? And the building instruction. So if you can just open the link, then you can find out all the document, and I will share the recording after the session.
Great, thank you very much. So this is the QR code for the same link that is in the chat,
Yes,
right?
yes.
Yeah,
Yes,
cool.
yes.
Yeah, I got it open. Yeah, thank you.
Thank you. Okay, cool. We have small group for today. So I don't know if you guys want to chat or have more question. We can start from now.
Not a question, but hello everyone again, and thank you so much. Thank you, Barry. I just wanted to
Thank you.
remind you that based on the request that we received on the previous webinar, I shared the new data sheet to you, William. So if you like, you can also share that data sheet, maybe Zartaj or other people who are trying to have some workshops for the kids can use also that data sheet. So if you want with other material that you are sharing, you can also share that data sheet, but you can decide. It's not, it's just an offer, yeah.
Thank you.
Thank you, Kate, very much. Yeah, it's a really good advice. I don't see any
You're
reason we
welcome.
should not share it. I think it's really comprehensive one, and yeah, it should be really useful for many, I think, coaches or users out there. Yeah, sorry, I joined in the in the middle way, and I guess yeah, it's so consequent because it's the Easter holiday, and I guess many of those audience they are on the holiday now. But yeah, I appreciate this small group that we're here, and yeah, I really like the way that I mean the pace that Barry conducted this workshop. So yeah, I think it's quite straightforward and easy to follow, which is really great. Yeah, yeah. I guess I will check the recording as well, as I mentioned. Yeah, I missed most of the parts, so yeah, I will check the recording. Thank you, Daphne.
Thank you, William. Yeah, so I think that's everything for today. And yeah,
yeah. I'm not sure. Yeah, maybe we can. I don't know. Maybe we can add the like data sheet to the slides or something that we can share with the audience. Yeah, as what he suggested. I think it's really good.
so yeah, sorry, I will speak in Chinese. 智仁，你可以把那个 data 去直接放到你那个链接里面嘛，这样大家都可以下载。
哪一个 data sheet？
我等一下发给你。
OK。
Yeah. So I think Barry will put the data sheet into this link, then everybody
OK.
can download it. It will be easier.
Perfect. Thank you so much.
Right.
Thank you, Wahid.
You're welcome.
Yeah.
Thank you.
Yeah, it's great to be here.
Okay, great. I think actually this is the 3 session we have. I just because today we just have a small group. I just want to check. Do you think if we can have do you think this is enough, or I don't know? I want to hear from Vahi. Do you have like anything you think we can continue to doing this, or I think or so far 3 is good enough, or you think any topic or anything else we can add on and can support the future innovator sets?
Definitely we can continue, but if you're asking for the next month, I can't give you clear information about the topic. But I shared the link, and we are also receiving lots of feedback from different people, and some countries, they received the packages and they will try to test them, and we may receive more information and more questions, and sometimes maybe some issues. And in that time, I can share you some topics, and we can plan another webinar to answer those questions, or maybe based on the request, we can work on another topic. It was today was mostly related to the movement and motors and DC motors and servo motors, but maybe later we receive some questions about how to use the sensors and the combination of different sensors. So maybe another webinar related to the sensors and the combination of the sensors would be nice. But if you're asking about the exact date and exact topic, I can't say anything clearly now. Maybe in June, or in June, I think, or July, early July would be the time that we received most of the comments, and lots of countries started to test the packages. And yeah, definitely we can plan, and it's very useful. So if the countries share these webinars, all the students can try to do it by themselves. When they have time, they can start building, they can start coding. So this type of information is very helpful, but give me more time to tell you when is the proper time and which topic.
Sounds good. Thank you.
You're welcome.
Yeah, so I think, yeah, we're good for today, right? Okay.
Yep.
Yeah, so before like Vahil mentioned you have some like question regarding the sensors and everything. Probably you send us maybe the sample code you use, and also if you have a video record, and then we can see what's the issue or problem. I don't know.
Definitely. Yes,
Okay,
I will
thank
share
you.
with you. So I will share the
With William.
problem with the PIR, yeah, and
Mhm.
DHT11.
Okay.
Yeah, I will share with you the code and yeah, a short video. Then you can investigate and get back to me for any problem. Maybe I'm doing something wrong. So you're experts and you can help me. Yep.
Thank you. Thank you for
Thanks
the
a lot.
details in testing. Okay. I think, William, you want to say something, or we're good for today?
No, I think all sounds great. Sounds great. Yeah, I really agree with Vahid's comments, right? So we can let it fly for a while, and then we get some feedback about how we continue such webinars. Yeah, would be really great. Thank you, guys.
Okay. Thank you, everyone.
Thank you, guys.
Bye-bye.
Thank you so
Barry.
much.
Thank
Bye.
you. Thank
Have a
you.
nice
Thank you,
day.
Vahid.
Bye-bye.
Bye. Bye-bye. OK，没问题，谢谢。
好，
我
谢谢。
等一下有一个那个，就是有一个 data sheet 我给你，然后你帮我放到里面。
到那个，OK。
好，OK，谢谢，拜拜。
好，谢谢，拜拜。